Welcome back. We're in lesson 72 in Algebra 1. We're going to talk about factors that are sums. So sometimes we have problems that look like this. And this is 72.1. We're just going to jump right in. We have, let's see, a plus b times x squared is being, we have this being subtracted from that. We have a plus b times x. And then we have 6 times a plus b. Well, we already see this is a common factor because these are being multiplied times each other. So it's like they've already factored it out for you. You don't even have to think about it. We can just say a plus b times, we factor it out of each one of these, and whatever's left behind becomes our trinomial. Minus x minus 6. How simple was that, right? And we've already got it in descending order, so now we can factor this. So we say a plus b, and then we create our pair of parentheses. We factor x squared, which is x times x. Now we need the factors of negative 6 that are going to equal a negative 1, right? So that would be, oh, I don't know. Let's try 3 and negative 2. And then we have negative 3 and positive 2. So if we combine these two, we get a positive 1. So that's not it. If we combine these two, we get a negative 1. And that's what we're looking for. So these are the factors we want. So negative 3 and a positive 2. And that's how we would completely factor this up here. We take what's already factored for us and just put it on the outside and let all of these individual terms fall into place. So let's try another one, 72.2. So let's start, we have x plus y. That's going to be our group factor, obviously. Write as I write so that you have this down. All right, so let's factor out our binomial. So we have x plus y. And now we can drop our numbers that's left. We have x squared plus 9x plus 20. That's what's left. So now we can factor that. So x plus y, and then we create our pair of parentheses. We factor x squared, that's x times x. Now we're looking for the factors of positive 20 that equal 9 when combined. So we have negative 4, negative 5, that equals negative 9. That's not it. So we have positive 4, positive 5, that equals positive 9. So those are the ones we want. So positive 4, positive 5. All right, so that is the whole thing up here completely factored. Very good. All right, we have one more like this, and then we'll move on to pyramids and cones. So 72.3 is this. Write as I write so that you can you don't have to pause and write it down later. You can go ahead and get some of it done as you watch the screen. All right, so here's what I would like for you to do. I would like for you to pause the video and solve this problem yourself, and then come back and press play and see if you got the right answer. All right, if you got m times x minus 1 times x plus 2 times x plus 5, then you got the correct answer. We pulled m times x minus 1 from each of the terms. Here's the m and here's the x minus 1, the m and the x minus 1. And that left us with m times x minus 1 times x squared plus 7x plus 10. So then we factored this trinomial. So we did our two sets of parentheses after we wrote the prefix here. And we said that the factors of 10 that give us 7 is positive 2 and positive 5. So m times x minus 1 times x plus 2 times x plus 5 is the correct answer. All right, so let's move on to pyramids and cones. Let me clear this page. So a pyramid is a geometric solid with one face a polygon called the base, and the other faces are triangles, and they're the lateral bases. So for instance, if you had a square base and all of the sides were triangles, it means that each side would go up to the top. So you'd have a side on the back, on the front, on the left, and the right, because this would be 4 sides on the bottom. The number of sides on the base dictates how many triangle sides you're going to have around the top. Okay, so the pyramid above, right here, we're going to call that a right pyramid for the sake of math. It may not exactly look like one because Miss Tracy's drawing skills could use a little bit of practice. But let's move on. So here's the terminology that we want to learn. Where all of the points of the triangles come together, that's called the vertex. Okay, and that makes sense if you think about this being a line and this being a line and this being a line. All of these meet together, that's the vertex. Now the little corners where they meet, this is called a lateral edge. Lateral means side, so this is an edge on the side of the pyramid, right? It's like a corner. Now the actual flat surface of this, right here, that's called the lateral face. And face comes from the word surface, right? Meaning flat face. So this would be the flat face of one of the sides of the pyramid. Now this part at the bottom, this is your base. Okay. Let's see, the part here that goes up and down, that measures from the vertex down to the base, that is called your altitude, which is another word for height. Okay? Altitude and height are the same thing. It's also called the axis, just in case you want to know that. Now the only other thing that's a little bit different is we have what's called the slant height, and that goes from the vertex down the, let me use a different color for that. Goes from the vertex down the lateral face to the edge of the base, and that is called the slant height. And we will be using the slant height for various things. Okay, so that's a pyramid. So the other shape we want to talk about is a cone. And a cone is, well, you know, if I could actually draw it, my pen is doing wonky things tonight. It's not wanting to do well. Let me see if I can do it again. All right. All right. There we go. A cone is a pyramid, but the base is a circle. Right? So you have some shading here that makes it look more cone-like. I'm going to try to kind of make that look good for you. So you kind of get the idea that that is indeed a cone. Think ice cream cone, right? Upside down ice cream cone. Let me come back in here with this and just kind of, so now you kind of see that's the back of it, right? So a cone has some of the same parts. At the very top where everything meets, that is the vertex. And it has the whole thing all the way around is the lateral surface. Now notice we don't have a lateral edge because it's a circle, so it's smooth, right? We don't have a lateral face either. Instead we have lateral surface because it is all one. You can't tell where it stops and starts, right? It's all one dimension or one flat shape. But we still have a base, and we still have an altitude from the vertex to the base. So that's our altitude, and it is also the height of our cone. And it is also called the axis as well. Right, so they have some similarities here. But that is all that we have. Now, the circle base at the bottom still has everything that a circle has. So it has a radius, and it's going to have a diameter as well, which is 2 times the radius. Now, the other thing, I'm going to use red for this, the other thing that it also has from the vertex to the edge of the base is a slant height. So they both have a slant height as well. Okay? So those are some things you need to sketch those in your notebook with, this should be an S, sorry, with all of the words illustrating the different parts so that you can keep up with what's going on with the pyramid and a cone. Now the volume of a pyramid and a cone, we want to find the volume of these shapes. It's exactly the same formula. It doesn't change because one's a pyramid and one is a cone. They are the same, which is pretty awesome. The volume of a, let me see if I can do this right. The volume of a pyramid or a cone is going to be 1/3 of the base times the height. So what we would do typically is we would say base times the height divided by 3. Right? That is the volume of a pyramid or a cone. So you don't have to worry about having a special dimension for that. So what you would do is you would take the area of the base, right? So the area of the base times, oh goodness, times the altitude. That's this right here. Right? That's what you would do. Times this. Or times this. Area of the base times the altitude, and then you would divide that by 3. And that is how you'd find the volume of a pyramid or a cone. So let's try that. If you haven't written this down, pause and do so now. I'm going to clear the page. And let's see what I can do. All right, I found a cool picture, so I didn't have to draw that again. So we have a right rectangular pyramid, and it is a 4-sided base. So let me put in some dimensions here. On this side, we have, this is 9 inches long, and this side of the base is 7 inches long, okay? Now, the height here is, let me draw that in. The height here is 8 inches for the height. All right, so we take the area of the base, So the volume of our pyramid is going to equal the area of the base times the height divided by 3. So the area of the base is 9 times 7. Okay, so that's going to be 9 times 7 first, and then the height is 8, so times the height. All of that divided by 3. Now there's a reason why I did not go ahead and multiply these out, and that's because 9 is 3 times 3. So I can factor a 3 out of this, right? So I could easily say that this is 3 times 3 times 7, and then that's times the height of 8 divided by 3, so I'm going to factor this 3 out of here. So now I have 3 times 7 times 8, so that's 21 times 8, that's 168 inches, and it's volume, so it's cubed. All right, awesome. So if you don't know how I got that, I said 21 times 8, and that's what gave me 168. All right, 8 times that is 8. 8 times 20 is 160, 168. All right, awesome. That's hardly any math at all. Hardly any math at all. Now you could have just as easily skipped this step, right, and then done the division. Let me show you what you would have gotten. You could have just as easily said 9 times 7 times 8 equals, divided by 3, it would have still been 168. So it doesn't matter. I like to do it this way because then it makes the number smaller so I can do it in my head. That's the only reason I like to factor. You still get the same answer, so it doesn't matter. So let me clear this. If you haven't written this down, this was 72.4. Okay? Pause and write it down. I'm fixing to clear the page, or I'm about to clear the page. And hold on. All right, I found a picture of a cone. Saves me from having to draw something really ugly. So we're going to use the right circular cone with a base of a radius of 6 foot. So this is going to be 6 foot is the radius here. Okay. And it has a height of 8 feet. So the first thing we have to do to find the volume is we have to find the area of the base. And we know that the area of a circle is going to be pi r squared. So pi times 6 foot times 6 foot is going to equal 36 pi feet squared. All right, so now we're going to do volume. So volume is going to be 36 feet squared times 8 feet. And that's all over 3, right? So again, what I'm going to do is I'm going to factor out my 3. So I know 36 is 3 times 12. So I'm going to factor out that 3, and I'm going to factor out this 3. So now I have a 12 feet squared times 8 feet, and that is going to equal 96 feet cubed. Oh, sorry. I forgot pi. So pi is in there. There we go. 96 pi feet cubed. And this is the answer that I'm looking for. I'm looking for 96 pi feet. I'm not looking for you to multiply pi. Stop right here. This is what I want. Let me rewrite this so that it's clearer so you can see what I did. So it was 36 pi feet squared times 8 feet divided by 3, right? So I factored the 3 out of here. I said this is 3 times 12. So I factored 3 out so I didn't have to divide later. So that left me with 12 pi feet squared times 8. 12 times 8 is 96, and then you have your pi symbol, and then you have feet twice, 3 times, so that's volume cubed, 96 pi feet cubed. All right. Pretty awesome. So that's how you do the volume of a pyramid and a cone. So now let's talk about doing the surface area. So let's clear the page. Surface area is just going to be the sides of your pyramid. And in this case, we have 4 sides, right? We have the back and the front and the left and the right. Now, this is going to be a square, and this square is 5. And we have to find the slant height. When you want to do surface area, you need the slant height. Because if you think about it, this is a triangle here, right? So you need to have the height from here to here for that triangle, not from here to here for volume. We want to find the triangle area on the side, not the volume of the entire cube. So the first thing we're going to do is we're going to do the square on the bottom. So the base is a square. We know that that's going to be 5, and what is this? Centimeters. These are centimeters. And the slant height is also 5 centimeters. All right, so the base is, you've got 5 here, and because it's a square, this is going to be 5 here too. So this square on the bottom is 5 centimeters times 5 centimeters, which equals 25 centimeters square for the base. So now we're going to do the triangular side. Now, because this is a square, it is a regular polygon. So that means we have 4 sides that are exactly the same. And the formula for a triangle is base times height divided by 2 for the area. Okay, so the base in this case, I'm sorry, not base times height. Well, I guess it is. But it's the width of the base times the height divided by 2. All right, so yeah, I guess it is just base times height divided by 2. So the base here is 5 centimeters, and the slant height is 5 centimeters. So that's going to be 5 times 5 divided by 2. 25 divided by 2 is going to be 12.5 centimeters, because 25 divided by 2 is that. All right, and that's going to be squared. But guess what? We have 4 identical. So we're going to multiply that by 4. So that's going to be, here, let me do this a different way. No, I'll do it this way. That's going to be 50. All right. So the other way I was going to do it, I was just going to do this and say 4 times the base times the height over 2, because they're 4 identical sides, and then factor out one of the 2's here. So it would just be 2 times 25 centimeters square, which would have been the same thing, 50 centimeters square. So either way you want to do it, you can multiply it by 4 on the front end and factor out a 2, or on the back end and just multiply straight across. Anyway, the surface area is, the lateral surface area is 50 centimeters. The base surface area is 25. So when we say 25 plus 50, we're going to get 75 centimeters square, because it's surface area for this triangle right here. Let me double check and make sure I got that right. Yes, that is correct. All right. So let's look at the surface area of a cone and how to solve that. So be sure to write this down in your notes. I'm going to clear the page. If you have any questions about that, please let me know, and I can either send you another video, or we can work together in person, or I can send you a resource that I have that might explain it better. Okay, so surface area of a cone. Let's see if I can draw this cone to actually look halfway decent. All right. And it has a slant height, and slant height is usually pictured on the side right here. This is the height of the cone, and this is the radius of the circle at the bottom. All right, the slant height is 10 meters. The radius is 8 meters. And we don't even need the height of the cone at all. So here is the formula for the surface area. We take the area of the base plus the lateral surface area. All right, so the area of the base, we know what that is. That's going to be pi r squared. And we're going to add that to the lateral surface area, which is going to be pi times the radius times the slant height, which is called L. So pi r squared. The radius is 8 meters. So pi times 8 meters times 8 meters plus pi times a radius of 8 meters times the lateral surface, or the lateral slant height, which is 10 meters. Okay, so 8 times 8, meters times meters, we have 64 meters, 64 pi meter square plus 80 pi meter square. So 80 and 60, that's going to be 144 pi meters square. And that is the answer. So write all of this down. This is how we find the total surface area for a cone. All right. And that's all we have for lesson 72. And I will see you, I'm going to put it right here, that this is equals L. Okay. I'll see you in lesson 73.